chance. So this is a foundations course. Foundations meaning we do go right back to grade 11 stuff. We do spend some time revisiting a lot of the grade 11 content to make sure that you have a solid foundation for the grade 12 content. And that's what we are busy building up towards at the moment. We are looking at parabola, and so we're working our way through all the functions before we're going to get to inverse functions. There really is no point trying to attempt the inverse functions if you have not developed a good grasp of the functions in general. You will really battle with the inverses if you are not so strong on your foundation. So that's what we do in this course. We really spend time on the foundation to make sure that you can handle the grade 12 stuff. Having said that, all the grade 11 functions are examinable in grade 12. So it's not like we are wasting our time here. It is definitely, you will get parabola, straight line, hyperbola, and exponential graphs in the grade 12 exam as well. So it is all very, very valuable knowledge that we are revisiting. Rightio. So we are going to kick off with a past exam question from a departmental paper. On Tuesday, just if we can maybe do a run through, especially for our newbies, we did sketching parabola, we did finding the equation of parabola, and we did completing the square to convert from the standard form of the parabola to the turning point form. And we spent quite a lot of time focusing on that because that's a key skill that you need to understand. In terms of going forward and maybe making a checklist for yourself, you have to be comfortable, and I'm going to make the checklist, I'm going to write it here, a sort of self-check that you can do when it comes to all the graphs. Okay, so for each graph, you have to be able to sketch that graph. So we are now doing parabola. You have to be able to sketch a parabola. You have to be able to find the equation. So do it the other way around. If given the sketch, find the equation. You have to know all the characteristics of the graph. So if it's a parabola, it's turning points, characteristics. So I'm going to list specifically for the parabola, the turning point, the domain, the range, the shape of the parabola, and then you have to be able to interpret some of the transformations, like if it's been shifted up or down, left or right, if it's been reflected in the x-axis or the y-axis. You have to be able to find intercepts with all the axes, so both x and y. And if there is, it's a common question to have a parabola and a straight line. So if you have a parabola and a straight line, you have to be able to find the points of intersection. So if you are able to do these things, you can most certainly pass this section quite comfortably, even with like 50 to 60%. These are some of the basic things that you have to be able to do. And from there on, you can move on to doing some more complicated things like interpreting. Okay, so we're going to spend some time making sure that these concepts are in place and that you are comfortable with these basic things. Okay, this is the sort of way that you can make sure that you pass. Okay. So let's start here for question 4. Below are the graphs of f of x is equal to x minus 4 squared minus 9 and straight line g. So already we have to recognize this straight away as a parabola, and the parabola is in its turning point form. Remember on Tuesday we looked at the two different ways that the equation can be represented, the standard form and the turning point form. So here we've got turning point. Okay, so straight away we have to start thinking, okay, if this is a turning point form, I can already tell from the turning point, from the equation of the parabola, what the turning point is going to be. Okay, so this is all the things that are starting to go through your head as you get this question. A and B are the x-intercepts, okay? X-intercepts, one of the things on my list, you have to know how to find x-intercepts. And E is the turning point of F. C is the y-intercept of both F and G. So G is the straight line. Most likely we're going to be asked to calculate the equation of that straight line, but let's see what happens. Okay, the x-intercept of G is D, and DE is parallel to the y-axis. Okay, so this dotted line here is parallel to the y-axis. Okay, I'm going to leave that there for about 20 seconds. I just want everyone to really read what the situation is, what is represented here. Maybe jot down a few notes before we get to the actual questions. I just want you to spend time making sure you understand the question, just the situation and what is given. Okay, so we're going to kick off with the coordinates of E. And right away, I would like people to put their answers in the chat. What are the coordinates of E? Don't be shy, put your answer in the chat. Remember, we said that the parabola's equation is in turning point form. So it is fairly straightforward. Also look at the mark allocation. Tumelo, remember that the E has an X coordinate and a Y coordinate. Resego, while everyone is posting, you can quickly ask your question, unmute yourself and ask your question, Resego. No worries, Tumelo. Okay, Resego, I'm not getting an answer from you. Okay, the Resego posted her answer. Well done. Okay, right. So we can definitely read off the coordinates of the turning point from here and here. X coordinate of the turning point, Y coordinate of the turning point. So that is 4 and minus 9. Okay, well done. Calculate the coordinates of A. Right, so what is special about point A and how will we find that? What is special about point A is that it is an x-intercept. So let's carry on and calculate the coordinate of A. That's right, Zamukukle. Now we calculate the x-intercepts by making y equal to 0. Well done, Zamukukle. That's exactly what we do. So we're going to take the equation and put that equal to 0. Okay, let's do that now, everybody. Remember this checklist that I've put up? These are the things that we must be able to do. So each Watobian in the house this evening must be able to find x-intercepts. And it must really become like 1 + 1. How do I find x-intercepts? Make y equal to 0. How do I find a y-intercept? Make x equal to 0. Colofelo has already found a coordinate for A. Well done. That was really fast. No pressure, everyone else. We don't have to be fast. We just have to be right. Okay, we're going to take the -9 over to the other side and get x minus 4 squared. Good, there's some answers coming in. We do seem to have 2 different answers. So who is right? I wonder. Okay, so we're going to take a square root. If we take a square root of 9, remember the square root of 9 can be -3 or the square root of 9 can be +3. So on this side, we get 1, and on this side, we get 7. Okay, so we are definitely in agreement about the 1 and the 7. But I would say A is definitely 1 and 0, and B is 7 and 0. Yes, that's it. It's a quadratic equation. Exactly. When we make y equal to 0, we get this quadratic equation, and for which we solve. Wonderful. Okay. We didn't have to give B. We would just ask for the coordinates of A for 3 marks. Now look at that. Those are 3. That's already 5 marks in the bag. Easy stuff. Okay, now let's think a little bit about 4.3. M is the reflection of C in the axis of symmetry of F. Write down the coordinates of M. So remember our axis of symmetry, we talked a lot on Tuesday about the axis of symmetry. The axis of symmetry goes through the turning point, which we said is here, 4 and -9. So it says that M is the reflection of C in the axis of symmetry of F. Write down the coordinates of M. Right, now first we should probably determine the coordinates of C. So C is the y-intercept of the parabola. It's also the y-intercept of the straight line, for which we don't have the equation, so that's not really helpful. But we need to, and it's 3 marks, okay? So it's a little bit of work. We need to determine what the y-intercept is of C, of the parabola, so that we can know what the coordinates are of C. So how do we determine a y-intercept? Who can tell me that? Put it in the chat if you know. X must equal to 0. Well done, Zamakukhle and Kolofelo and Tumelo. You're all right on the money. So we're going to take this equation and make x equal to 0. So I get 16 -9, so y is 7. So the coordinates of C is going to be 0 and 7. Okay, but we have to reflect C in the axis of symmetry of the parabola. So how are we going to do that? So to make a visual representation of that, it is going to be over here. This is going to be M. Anyone want to venture an answer? What is going to be the coordinates for M? Tueno says 8 and 7. 10 and 7. We're getting all different answers here. Eight and 7. 8 and 7. Okay, so I think we all agree that the y-coordinate for M is 7, but what exactly is the x-coordinate? Okay, so since we know what the y-coordinate is, we can substitute that in and find what x is. Okay, so Colafelo says from origin 0 to 1, so it's 7 plus 1 is 8. Okay. What do you think, Miss Coco?
I think she's onto something, but you know, I use the turning point rather than the origin and the point.
How did you do that, Miss Coco? Do you want to share with us?
Well, I figured because the line, well, our y-axis is parallel to our turning point, and our turning point sits at 4 and the y-axis is at 0, I can just flip that over and that's going to be 4 units from one to the other. And therefore I just have to take the turning point and add 4. And that's how I got to that. Yeah.
Yes, I agree. So from this distance, because of the symmetry of the parabola, that is 7. Oh, what am I saying? Not 7, 4. I'm looking at the 7. That's 4. And from here to there, because of the symmetry, must also be 4. So the coordinates of M will be 8 and 7. Yeah. Just the other way around, Michlali, your y coordinate is 7 and your x coordinate is 8. Right. Can we move on, everybody? That was a bit of a thinking question. Yes, I agree with you. I hope we can change your name, GDH SGL admin. Can we change your name, please, to your real name? Because I see you do give a lot of answers, so we do like to, know exactly who is actually giving the answer. But I agree, you can substitute, make y equal to 7, and then substitute it, and then solve for x. You could have done it that way as well. Quickest way was to do it with the axis of symmetry. Okay, so determine the equation of G in the form y equals mx plus c. Okay, so let's think about this for a second. We know that G goes through the y-axis at the same point. And then we can probably find what point D is. Point D is also working with the axis of symmetry. It is directly above E. So that is going to be halfway between 1 and 7. So that's also 4 units that way. No, sorry, 3 units that way. Because of the axis of symmetry, so then this must be 3 as well. So this is 4 and 0. I probably overcomplicated that a little bit, but yeah, that is 4 and 0. And we're going to need the gradient as well of our straight line. So we've got the y-intercept, it's over here at 0 and 7, and then the gradient we can calculate. And that will give us the equation of the straight line. Okay, so from this list that I put here, finding the equation is definitely part of something that you have to be able to do with all the graphs. Okay, so straight line equation, we need gradient, we need y-intercept. Let's give it a go, guys. Let's see if anyone can post in the chat as soon as they have the answer. I've given some clues here. I've given the coordinates of D, I've given the coordinates of C, and we need the gradient, but we've got 2 points, so we can calculate the gradient. Let's see if anyone can post in the chat for us. What is the equation of the straight line? Y equals mx plus c for this graph. I'm going to give it 2 minutes till 5:30 to see if anyone can post the equation of the straight line for us. So I was giving it with a question mark. Well done, everybody. Yeah, good. Just check your gradients. Those of you who are giving positive gradients, just make sure that that is right. Okay, and to get a little bit technical, you need a y equals 2 minus 7x plus 7. Okay, you need an x and a y in your equation for it to be a valid equation. Okay, wonderful. I'm going to start off by popping in the y-intercept. And then we have a gradient that we can calculate using those 2 points. So gradient, I'm going to go 7 minus 0 over 0 minus 4 gives me a gradient of 7 over negative 4. So the gradient is negative, which makes sense because if you look at the line, it slopes in the negative direction. Okay, so those are little checks that you must be able to do. Check that your gradient, what you're working out, makes sense with what is presented in the picture. If it is sloping in the negative direction, your gradient should be negative. Okay, so well done, everyone. That is indeed our equation, minus 7 over 4x plus 7. Great stuff. Okay. Let's see, how's everyone doing? Simo, now you ask me which year it is. I think this was a supplementary paper, so a March paper, and I think it was 2016. I'm not sure. I normally do write down where it comes from, but in this instance, I have left that out. But I think it was a supplementary paper, so a March paper. Rightio. Let's see. Everyone, please put a thumbs up, thumbs down in the chat. I just want to check in how everyone's doing and if we are still strong. There's a question. Where does the 7 come from? Cindy's was asking where the 7 comes from. The 7 comes from the y-intercept. If you read earlier on in the question, it does say that C is the y-intercept for both the parabola and the straight line. So that's how we know that it's the 7. Okay. Okay. Great. Quite a few thumbs up. Well done. Mhlale, you got your hand raised. You can quickly ask your question. Unmute and ask.
Sorry, it was a mistake. I wanted to thumb up.
Oh, okay. Thumbs up. It is. Ms. Coco, maybe just check in with Asakundwe.
Will do.
If the thumbs up, if we can turn that frown upside down. Right. Now that was the warm-up. Let's get cracking on this question. Lots happening, lots of lines and stuff. Be ready. I think tomorrow, guys, you're going to be so ready for your exam tomorrow with these parabola and straight line and stuff. Okay, so in the accompanying sketch, not drawn to scale, the graphs are shown. So we have, again, a parabola and a straight line. Find the coordinates of C, the turning point of the curve of F. Okay, so this one, this equation is in standard form. Different to the one we just did, that was in turning point form. So we have to handle it a little bit differently. So find the coordinates of the turning points of C. I want to see 4-point C. Who can remember the formula that we can use when the equation is of the parabola is in standard form, the formula that we can use for the turning points? Who can pop it in the chat for us? Virtual silence. Minus B? No, it's more than that. It's not just minus B. Minus B over 2A. Okay, well done. Okay, so we know our work. That's wonderful. Right, so that's what we're going to use in this instance. We are going to use the formula for the turning point minus B over 2A. But that only gives us the x coordinate. Remember, we still need to calculate the y coordinate. So, let's start with the x. Okay, Leako, when we calculate the turning point, y is not necessarily equal to 0, okay? Y is equal to 0 when we do x-intercepts. Make a big note for yourself of that so that you know when to make y equal to 0 and how to calculate the turning point. So the turning point is minus B over 2A. Where does the minus B and the A comes from? That's right, Mark Adams. We are, once we have the X, we sub it back in to get the Y. Okay, so the minus B comes from our equation, so that's minus 2 over 2 times A is minus 1, and that gives me 1. And we sub that back in, so we're going to figure out what y is. Okay, so that's 5 minus 1 is 4. Wonderful. Quite a few of you got that very quickly. Well done. So C is 1 and 4. Okay, so once again, these are like non-negotiable marks. Okay, you got to get this. This is definitely non-negotiable. So subbing into the formula as a mark, finding what x is, subbing in again, finding what y is. That there's your 4 marks. Okay, so yeah, non-negotiable marks. Determine the length of KC. Okay, well, now that we have the turning point, and I really like putting on my sketch the things that I calculate, just so that it actually populates and it's in front of me, I can see it. So maybe try that as well if you are struggling with graphs, like put the information on the sketch so that your brain can put it all together and it's not in separate places. Okay, so determine the length of KC. KC is just the vertical length, right? So KC is going to be 4. Well done, everybody. Yes. on the money. And then for 12.3, we are, if A and B are the x-intercepts, find the length of AB. Okay, so you see how they subtly just changed the question. Now they're asking for the length of AB, but to get that length, we are going to have to find the x-intercepts. So again, must be able to do this in your sleep. We put this equal to 0, minus x squared plus 2x plus 3. And for this one, we are going to factorize. With the equation equal to 0, factorize. So x is 3 or x is minus 1. So obviously my A is going to be where the minus 1 is, and where B is, that's going to be 3. So what is the length of AB? AB is 4. Four units. Well done, Mpilo and Mkhlali. Again, a few of you getting this right. Well done. Okay. Now we are going to determine the equation of G. You can, Lahako, but this is such where the factorizing is really straightforward. Just use factorizing rather, because the formula is going to take you some time, a bit longer. Okay, you do have, remember we work on a mark a minute, so there's 4 minutes for this 4-mark question. So technically speaking, yes, but the formula takes longer. So if you can just factorize it, then just go ahead and do that. How do we know it's 4? Remember the length, they're asking for the length. So if A is at minus 1 and B is at 3, we're literally looking at how far apart is minus 1 and 3, and that is 4 units. That's how we get that, guys. Please put a thumbs up if you're happy with that. And then everyone else, let's go on to 12.4, where you have to find the equation of G. Cool, thanks everyone. Hey, Dean, Kayla. Good stuff. Okay. Let's do the equation of the straight line again. $12.4, I'm going to give everyone till about 17:43 for that straight line. Oops. So. Mkhlani's writing thumbs up. Well done. Message received, Mkhlani. We got you. Loud and clear. The equation of G. Now remember, this is the same y-intercept as the parabola. 0 and 3. If you are done with 12.4, please feel free to go on to 12.5. Again, a nice question about mirror images. How is it the same though? How is what the same, Zamokukhle?
I think Zamakushe might be asking why that coordinate for the parabola and for the straight line are the same at that point 0.
Oh, because they both, the parabola and the straight line both go through that point at D. And at B, in fact, it's they share an x-intercept. Okay, so for straight line, just like the previous question, we need y equals mx plus c. I'm going to put in the y-intercept first, so that's 3. And then to get the gradient, we've got 2 points here. We've got 0 and 3, and 3 and 0, because this is our x-intercept. Okay, so some of you are giving the answer already. Wonderful. I'm going to quickly work out the gradient over here. Hopefully I'll catch up with everyone else. So 3 minus 0 and 0 minus 3, and that is going to be minus 1. Great. Yes, and thanks, Ms. Coco. It is very important, guys, to remember your x and your y. Otherwise, you do not have a proper straight line equation. Okay. Elizabeth, you can ask your question. Unmute yourself and ask. Ernest, check your gradient. Hi, Elizabeth. Do you want to ask a question? Gone. Okay, right. Let's see if we can, for those of you who weren't quite sure about this question here about the reflection, let's give this one another go. So D and H are reflections, mirror images of each other with respect to KC. Determine the coordinates of H. D is the y-intercept of F and G. Okay, so there we also have that confirmation, Zamakokle, about the y-intercepts being the same. Okay, so if this is my my axis of symmetry going through here, then we can follow that same logic that we did earlier in the previous question to find the coordinates of H. Okay, is Elizabeth sorted? Okay. Right, so the distance is going to be, oh, Sibusiso is giving the answer already, 2 and 3. X is 2. Yes, Lahako, well done. Anyone else want to venture? H is 2 and 3. Yes, that's right. Okay, so if we work with the axis of symmetry of the parabola, the distance from the origin to the axis of symmetry is 1, and because D and H are mirror images, they'll share the same y coordinate, and then it will also be another 1 from the axis of symmetry, 1 unit horizontally to get the x coordinate of H. So that's going to be 2 and 3 for H. Okay, and with that said, I hope everyone is happy with that. I'm going to hand over to Ms. Coco because it is quiz time.
No